Okay. Okay, yeah, sorry, it's a massive picture. A through J, basically. We got markers going everywhere, we got angles everywhere, tons of stuff. I'm going to put one more thing in there. Put 150 in there just for running giggles. So we can ask a couple different questions. Not drawn to scale by any means, so go with it. Definitely not drawn to scale. Okay, now, what you're looking at here, as you guys are still drawing, you're looking at a very large diagram, and the book, what they're going to do eventually in the homework, no, we're not getting homework today. What they're eventually going to do in the homework is ask you a series of questions about this photo. A bunch of questions. So it's going to have a little bit of mixed review, it's going to have some new stuff. So I thought this is kind of a good question. I'll put it up here, and I'll just ask you very similar types of questions the book would ask, and let's see if we can refresh our memories on some stuff and learn how to apply the new words we learned yesterday in that little PowerPoint I did. Can we apply the new words to said drawing? Okay, does that make sense? We're going to spend a lot of time on this drawing. This is like the one focus that I want to do today. Once we're through this picture, because there's a lot of questions on it, then what we're going to do is we're going to do 3 other drawings, but they're not like this. They're like easy looking drawings, and we're going to try to apply the stuff we did on page 41 to the new stuff, this stuff. So that's what we're going to do. Those last 3 questions we do go really fast. The last class was like snapping through them because they got the idea what they need to do. Okay, so I know some of you are still drawing. Sorry, it's huge. Here's the first question I want to ask. We're going to go kind of in order. I want 2 congruent segments. This is a review question. So they want you to refresh your memory. What is a segment? What does the word congruent mean? And can you name 2 of them? So I'll start with the obvious. What does the word congruent mean? Congruent. Things are congruent to each other. They are? Equal. They're the same. They're equal. What is segments? What are segments? What are segments? What do you think? What do they look like? Brian, you want to say it? No. Somebody else. Very fun. It's honesty. We'll go with it. What is a segment? A line segment. We're too bashful today. A line segment. Does a line segment have arrows? No. Okay, they start and stop, right? There's 2 endpoints, the sticks between. Okay, can somebody look up here, look at this picture, and tell me 2 segments that are equal to each other. So I need volunteers. So this is where you can just name one and somebody else names the other. What are segments that are clearly, without making it up, clearly congruent to each other? They're equal. Can somebody give me one of them? Name one of the segments. What do we think? I'll look you guys out.
CH.
Okay. CH. Not quite. They're too far. Too much. Okay. FG. I don't know if that one's equal to anything else. It's not clearly marked. What are the markings I'm looking for?
EH and AB.
Say it again.
Maybe.
All right, there we go. Now we're starting to see it. All right. The segments that are equal are these 2. They have the markings. Those little markers mean they're the same length. Clearly, without even having numbers written in there. So AB, that's one of the segments, and EH, that's the other segment. Now, how you write that they're congruent to each other, you write the equal sign, you put a little tilde above it, the little squiggle above it. That means that they're equal in size, shape, and measure. Those little markers mean that. You can tell from the drawing. That's something we did in the very first section of chapter 1. I thought we probably should review that. It's been a long time since we've seen that. Okay, do we understand the first question? congruent segments. Now, they could do other things instead of the markers. They could say that, I'll go kind of the FG route, maybe this is like 10 centimeters, and this stick over here is 10 centimeters. So then, yeah, these two sticks could be equal to each other. They might tell you that. So those could be easy things to spot. Okay, second question. Second question. I want very simply put, an acute angle. An angle that is acute. So what do we know about acute angles? Say again? Between 0 and 90. So can somebody look up here and name one angle? There's a lot. Name one angle that is definitely acute.
BAF.
BAF. Okay, that's this angle right here. I agree with that. BAF is clearly one. You can see that. BAF, the 3-letter system, right? B, that's one of the walls, A is the vertex, and F is the other. That is clearly less than 90 degrees. I like it, that's good. Can somebody name another one? Let's go with a different one now. Name another one. Okay.
FEG.
FEG? FEG, okay, that's that. F E to G. I'll go with that. FEG. I like that. That's another good one. Now, somebody else. I don't know. Just keeps answering everything. Doing well, buddy. But somebody else now. FEG. Don't be afraid. Make some mistakes. Throw it up. JGI? Yeah, I'll go with that. I like it. JGI. That to me looks like it's cute. I'll go with that. That's this one right down here. Okay, do we get the idea what acute means though? Okay, less than 90. Now, here's ones that were clearly marked. I'm surprised you guys didn't pick them. Like this angle up here. That was 30. I'd have picked that one first. So that is what? Angle BCE? Or you can call it ACH or ECB. I don't really care if it's 30. You could have picked this one. That one was marked 60. I would have went with that one. EFG. That angle, EFG. So I'd go with like the obvious ones. You guys are like spending way too much time thinking about that. Okay, let's go to the next one. So let's go with, I want a right angle. So these are, if you haven't noticed, these are all the review questions. But they kind of lead you into the new stuff. A right angle, please. FEC, okay, good. Angle FEC. That is this angle right there. What gives it away? Yeah, the little red box, right? The little square box. Means it's 90. Now, here's the thing you also need to know. This is something we did not discuss yet. This is brand new. Anytime your picture gives you a 90-degree, perpendicular symbol, the right angle symbol, the angle next to it is also 90. So this angle right here is also 90 degrees. You need to know that. That's something that's automatic. It's one of those common sense things. The reason why it's common sense. Do you agree that this makes a straight line? Okay, it's a straight line. It's supposed to be. I'm a terrible artist, but you get the idea. This is supposed to be straight. And if this is 90, the angle next to it has to be 90, because what does a straight angle make in terms of number? 180. 90 plus 90 make 180. So the angle next to it has to be 90. So that's how it's like common sense. You just have to know that. Okay, are we good with all the kind of review questions? Let's get to the new stuff now. The new words we talked about yesterday. The new words were, we had adjacent, we had perpendicular, we had linear pair, vertical, complementary, and supplementary. We've got to get through those words today to see how do they apply to this so that you can understand what the words mean. So let's start with that first word that I talked about. Let's talk about adjacent angles. Okay, adjacent angles. Okay, that's me. That must be some dates. Adjacent angles. Well, we talked about yesterday. This was the new word on our PowerPoint. Adjacent angles are angles that are side by side. They're literally next to each other. That's what I think of. Now, the book definition was there are two angles that are on the same plane. They share a common vertex and a side. Okay, so they're next to each other. So can you name two angles that are side by side?
CEF
Okay, CEF. Okay, so hold on. Angle CEF
and FEH.
and FEH. Okay, let's talk about those two angles. So CEF is this angle right here, and FEH is that angle right there, that big angle. I agree, they're next to each other. Do we agree that those two angles are side by side? Okay, CEF, that's this angle, and FEH. Okay, that's good, that's one example, I agree. Another one. Nope. Anyway. Words are hurricane. Alright, what else do we got? Let's get some other volunteers here. Otherwise, I'm going to volunteer you as tribute. Okay, where do you go? What do you got?
BGA.
Okay, BGA.
Age.
So BGA, right?
Yep.
And what else? BGA, and what was the other one you said? Okay, I'll go with it. I'm going to go with that first one. She said BGA. BGA, that's this angle right here. And I want the angle next to it. You have a lot. There's quite a few angles you can pick. Anyone want to pick one? You got one?
EGA.
Say it again.
EGA.
EGA would be overlapping. I don't want to pick that one. Maybe EGB. Let's do that. EGB. That's these two angles. So BGA, that's this little wedge, and EGB. EGB. That's that angle right there. E to G to B. They're side by side. Now you had a lot of options. That was actually a really good choice to pick that area, because even if you picked this BGA, you could have picked this angle next to it, this one over here, because these are side by side. You could have picked this large angle over here. You could have picked this large angle down here, or this one. Like, you have a lot of options for angles that are side by side. That was a good choice in that area. Another common one that I'd pick for angles that are adjacent to each other, I'd pick these two. Those are kind of easy ones to see. BAF and FAG. Right, those. Boom, boom, boom. So those are side by side. You could have picked these two over here. These two, really. Adjacent angles don't need to be the same size. So don't feel like they have to be equal to each other. They're just side by side. Okay, questions with that word though, the word adjacent. Now I think probably the most common, maybe the part that people get uncomfortable with on this stuff was that you have to give the 3-letter system, right? That's probably the hardest part. It's like you got to figure out how to write 3 letters in the right order. So if I was picking these two angles for that, this angle, just put C in the middle of it. So DCE. So that was that one, DCE. And then this angle right here is BCE. So just put C in the middle because that's the vertex. And just go one way and go the other way. That's just how I think of it. So those are adjacent angles. Okay, are we good with the word adjacent though? Next to. They don't have to be equal, they just have to be side by side, not overlapping. But thank you for the volunteers. Very nicely done. All right, let's go to the next one. Let's go to the next. What do we got? We have, we were talking about perpendicular. Perpendicular is 90. We already have some perpendicular things there. Let's go with linear pair. That's our next word. Okay, a linear pair. Okay, so if we think about this word out loud as you're writing it, a linear pair has to be a pair of angles, obviously a pair, but they have to make a line, a linear line, right? A line. So two angles that have to be adjacent to each other, that have to be side by side touching, but they make a straight line. We have a lot of options here. And they have to make a straight line between them. Okay, so Nolan, what do you got? What's your first pair, do you think?
ABF
Okay, ABF. Okay, so I'm going to say that one. So
and FBC.
Okay, ABF and angle FBC. Okay, that ABF is this angle. That's A to B to F, and FBC is that angle. I agree. If they're side by side, they make a straight line. That's a good pair. Okay, these two do make a straight line, and they're side by side. This is the straight line between them. Okay, does that make sense? Okay, linear pair. Now, we've also talked about linear pair. They're also supplementary. They have to add up to be 180. So since I know the fact that these are linear pair, they make a straight line, these are supplementary, they also have to make 180. So this angle is also 30. Okay, that's something you need to think about. That they have to add up to be 180. Okay, there's a lot of options for linear pair. There's so many, in fact, I can't even list them all. Just because of just the idea of what a linear pair is. These two are linear pairs. We have like this angle and this angle down here. We have these two, we have these two, these two, these two. We have like this big angle and that one, or this big angle and that little guy, this angle and this big one down here. So we have a lot of options for straight lines. In this picture, you just have to pick two angles that are next to each other. Questions on a linear pair? Okay, digging into the next one. Vertical. Vertical angles. You don't remember vertical. Vertical angles are formed by straight lines crossing each other. Straight lines that cross. But vertical are angles that are not next to each other, but are across from each other. They're across. What I would like you to name is two angles that are vertical to each other, but they're acute. Now, to give you an idea, I'm going to draw this. So here's vertical angles, right? There are two straight lines there crossing, making like a little X shape. These are vertical and acute. They're across from each other, straight across. What do we know about vertical angles, though, other than just being across from each other? What do we know about their numbers? I hinted at this yesterday. If I told you this angle here was 20 degrees, what would this one down here be? 20. It's the same number. Vertical angles have the exact same digit. Now, obviously, the angles over here and here, these are also vertical, but they're definitely bigger than 90 degrees. Let's say this is 160, then the angle over here would be 160. Get the idea of like how vertical works? Okay, so up here, let's look at this picture. Can we name two vertical angles that are acute angles? Okay. So no one give me one if you have it.
AFB
Okay, AFB, angle AFB,
and GFE.
GFE. I agree with those two. Okay, GFE is this angle, and AFB is this one, A to FB. So they're both acute, they're both 60s. So that's a good way to do it. So I could transfer that 60 up here. Okay, anyone else have another pair? Is there any others that are up here? Okay, okay, please. Yeah.
IGH.
Okay, IGH, okay, that's this one. Angle IGH, good, keep going.
Oh, AGF.
AGF, good. Yeah, that angle right here. This one. Okay, that's AG or FGA, or how do you say it? AGF? That's what you said? Same thing. Okay, those are good. Yeah, these two are vertical. They're clearly less than 90. They're straight across from each other. We have a lot. There's more. I just thought it was kind of fun to kind of look at those. Okay, questions at all about vertical? We're going to see that later. It's one of our examples. One of the three weird pictures I'm going to draw up later. Okay, those are a majority of the keywords there. Linear pair, vertical. We've talked about adjacent angles. The last two words we need to discuss. I'm not going to write up everything up here. I just want you to see it. So I'm going to get rid of all these extra stupid marks I don't really need here. All right. Let's get rid of all these weird dots everywhere. Okay. So we're back to ground zero here. Okay. Here's the words we need to talk about. These are the last two. Let's talk about the first one. Complementary. Complementary. Complementary yesterday. What do these two angles have to add up to be? 90. Okay, complementary means corner. They're adding to make 90 degrees. Not just that it is 90, they add to make 90. So up here, there's a lot of different examples you can pick of angles that can add up to be 90. I need 2 angles right now that you know for sure make 90. Okay, so Nolan, give me one pair.
BCE.
Okay, so BCE, that's this angle right here. And
EFG.
EFG. EFG. That's this angle down here. That's EFG. I agree. 30 and 60 make 90. The weird part about complementary, they don't have to be next to each other. They have to add up to be 90 though. They can be across the picture. Okay, that's good. Another pair. Okay, what do you got?
ABF.
ABF. Boom, there's that one. ABF.
And let's go GFE.
GFE. I'll go with that. GFE. That's this angle right here. Those add up to be 90. Complementary. Easy. Now, here's my question. What about these two? What about those 2 angles? Are they complementary?
Yes.
Ooh, you say no, we say yes. Let's get some more opinions. What do you think? Yes or no? Raise your hand if you think yes, they're complementary. We got a couple. Raise your hand if you think no. Okay, we got a couple. Raise your hand if you're like, yeah, I don't know. All right, there's a couple. All right. So, here's the thing. What does the little box mean?
90.
They have to add up to be 90.
And then the line
They're
splitting it in half.
I know that I don't have numbers put in there. I don't have 30s and 60s. But since the box is sitting there, this is automatically 90. Yeah, these two, in theory, are adding to make that exact 90. So they are complementary to each other. So I could have said FEG, that's this one, and GEH. Those have been complementary as well. Because you can see that they're adding to make the 90-degree marker, the perpendicular symbol. Okay, does that help? So good examples. Thank you for all the volunteers so far. Okay, the last word, supplementary.
180.
180. They have to add to make 180. Add to make 180. 2 angles, adding to make 180. Give me one pair.
FBC.
Okay, FBC, that's this one.
No, ECB.
Say again.
ECB.
ECB. Yeah, that one. Angle ECB. Okay. FBC was this angle. EBC is that one. 30 and 150. That makes another pair.
CEF
CEF. That's that one.
and FEH.
FEH. That's that one. They're meant 90 90 make 180. We have a lot. In fact, here's the thing. I already have a pair on the board. Anything that's a linear pair is also supplementary. So ABF, that's this one. That's A to B to F. And FBC. There's that one. They could be side by side. They could be across the picture. So I could have picked a lot of different options. Okay. Questions at all? You guys are already back. Okay, questions on any of the vocab words we've talked about? Welcome to Stacy. Okay, we have new drawings now. We have 3 last drawings I'd like to put on the board today, and these go really quick. We spent a long time on that. So that is just kind of a review. Hopefully these words make a little more sense to you. You feel a little bit better about them. Maybe not perfect, but you feel better about them. That's what I'm hoping. All right, so here's our next drawing I'd like you to put. We're going to stick with some of the easy ones here. All right, we're going to try to explain this as we go. This is the first drawing that I'd like you to write down. 3 drawings. This is one out of the 3 we have left. Okay, so what you're looking at here, these are straight lines crossing each other. There's no 90-degree markers or anything like that. They don't tell me any of that. The question, what it says about these drawings, it says, the only instructions you have is find the values of each of the variables. Find the values of the variables. So find the numbers for X, find the numbers for Y, or A, B, and C, whatever letters they're putting in here. Okay. The thing is, when you look at these drawings, there's little things you can do. Not everything needs to be 90. I don't even know that these are 90 degrees, so don't assume that. But things you can do. Linear pair, vertical, those are like little things you can think about. Because obviously I don't know specific numbers here. So, do I have a vertical pair of angles up here? Vertical angles are the ones across the funnel.
The x minus 20 and 2x plus 10.
Yeah, these are vertical to each other, right? They're across the funnel. Vertical angles are equal. So what you're allowed to do is do this. 3x minus 20, you can set that equal to 2x plus 10. You can automatically set them equal. They're equal angles, right? They're crossed. So solve, you subtract the 2x, add the 20. Right? You're adding 20 to both sides, so it's doing this. Subtract the 2x across. It's the easiest way I can think of it. We can solve for x. Okay, so this turns out to be 1x, this turns out to be 30. Okay, so we found x is 30. But here's the problem. How do we find y?
Can't solve anything else in, so 9y has to be set equal to 9y.
Okay, so you're already starting to think about like the whole vertical thing, right? There's nothing down here. Like I don't even know that number. So you can set the 9y down here, but if you set them equal to each other, you can't solve. You'd subtract 9y's to both sides, you have 0 equals 0. So what do you think? How do I solve for y? It is possible. What was x again?
30.
30.
Oh,
Plug it back in.
30 on
Yeah, if you plug the 30 back in, here's what we have. Okay, so we plug the 30 back into x's. That's 90 minus 20. So this angle here is 70 degrees. That's this angle right here. And if I plug the 30 back in here, duh, it turns out to be the same number. Turns out to be 70. Now I think you can start to see what we can do here. I'm going to get rid of all these extra things. This is the same drawing. This is 70, this is 70, and I have a 9y and a 9y. Right? Just making it a little more clean to look at. Now what? Here's my question to you.
You need to hit 180, don't you?
Okay.
So the
What is this object? It's a segment or a line, right? It depends if they put arrows or not. So what do lines make? What do lines make in terms of angle?
180.
180. These two have to add to be 180. Makes a straight line. So the 9y would have to be a 110 if you think about it. The only way that this works, that this adds up to be 180, is if this is 110. I know it's not drawn to scale. They don't even say that they are. That angle 9y has to be 110 because it has to add with the 70 to make a straight line. So now you can solve this. You can divide the 9 over and figure out its decimal. You'll get tons of decimals on these problems. Does that make a little more sense what you can do with that? Now, I also had somebody in the last class, they did this really clever. They went, well, I can just add up all 4 angles together. What do you get if you add all these up?
360.
Yeah, 360. You get the same number. You'd solve it, it'd be the same exact answer. 70 plus 9y plus 70 plus 9y equals 360. You can do it that way too. Okay, questions at all about that problem? Okay, next drawing. Got 2 left. Where'd my little card go? All right, next one. Okay, here's what we have. And here, all right. Same instructions, it says above, it says find the values of the variables on the particular drawing, but it also has this. Line L, line M. What does that upside down T mean?
That's equal
Equal to what?
on each side.
Not quite. You're onto something. Not quite there.
You did this yesterday, but I can't remember.
Yeah, I can feel it.
Oh, it's perpendicular. What is perpendicular? 90. Okay, so that means L and M are making a 90-degree mark. So what you actually have here is you have a bunch of 90s. Everything is 90 up here. That's what you have. So how do I solve for one of these letters? Can somebody help me set up my first equation?
Just go 2y minus 6 equals y plus 15.
No, these are definitely not equal. They're not vertical to each other. They're not vertical. This entire angle could go vertical all the way down to here, but there's too many variables there. Okay?
3y plus 15 plus 3x equals 2y minus 6.
Okay, yeah, so you could add these two together, equal that one. But the problem is, I agree, you could do that. The problem is there's too many letters. There's X's and Y's everywhere. Thinking way too difficult about it. What's this corner up here?
90 equals 2y minus 6.
The 2y minus 6 is 90. That corner is 90 because they said it was perpendicular. So just set this equal to 90. Add this across. Divide by 2. Turns out to be 48. It's 96 divided by 2. Now that I know the y is a 48, now what can I do?
So it back in.
Plug it back in. So now I can plug all these 48s back in here. 48 plus 15, that's a 63. Plug that back in. This turns out to be 90 if I plug my 48s back in. Now what? I'm going to redraw. Some people just need to see this. This is 90. This is 63. This is a 3x.
63 plus 3x equals 90.
Yeah, exactly. And this is the part that you guys were saying earlier. I could add these two together and set equal to that corner. That's what you can do. 3x plus 63 should be equal to 90. These two added together should make the perpendicular symbol, or they equal the vertical angle across from it. I'm not going to solve that one, but you get the idea, right? What you can do? Okay. You can add the two corners together to make the 90. That's angle addition. They're adjacent to each other. You're allowed to add them. All right, last drawing of the day. This is the absolute last drawing, and then we're done. Last drawing here. X plus 4, 2y, and a 3x minus 24. Okay. No other instructions. There's none of this stuff that they talked about earlier. They just say find the values of the variables.
5x plus 4 equals 114.
Okay.
Be the first step.
Good. Now, why can I set these equal to each other?
Because they are vertical to each
They're
other.
vertical. They're straight across little funnels. Those are actually equal. Now, it's not 90. I know the picture looks deceiving. That's the way this is actually the way the book drew it. It looks like it's 90. It's not. It's 114. It transfers diagonally up. And again, how I know that? The straight lines cross. That's how I know where the diagonal ones go. So I can solve, subtract this over, solve this out. This ends up being a 22. Now what?
We get back in for 3x.
Yeah, plug the 22 back in. This turns out to be 66 minus 24, which ends up being a 42. Now we're in a weird pickle again.
Oh, take 360 minus 113. And divide by 2.
I redrew it, put in my numbers where they need to go. The 114 hops up. We already figured out that 42 in that one corner. Here's the last thing you need to think about. what should these make? You have these three angles. 180 makes a straight line. This is a straight line, so these three angles should add up to be 180. That's what you need to think about. Then you can solve from there. Okay, it might be a decimal, but you guys get the idea. Questions? All right, that's it for today. I thought it'd be kind of one of those days where we probably should review, talk about some more difficult problems, quickly kind of challenge you, put you in the spot a little bit. Thank you for all the volunteers that volunteer, because that is a tough thing to do, especially if you're not comfortable with this stuff. Might make mistakes. Monday, I will not be here Monday. Apologies, I won't be here. You'll have a sub, Mr. Granton will be here on Monday. Basically, he'll kind of review with you a little bit. I'll put a couple of comments he'll go walk through, and then you'll just have time to just kind of work. You can move around and sit in groups, whatever. Homework will be later in the week. Next Thursday, we have a test in here. I'm giving you kind of a heads up warning. We have a test coming up next Thursday. It's over this chapter. We'll start reviewing it on Tuesday and Wednesday. I always do a 2-day review. On Monday, I think Mr. Graham will probably hand out the practice tests. If he doesn't, I'll hand them out Tuesday and Wednesday. We always review it in class together, so you know how to fill it out. It looks pretty much like the real test. You get to take it home and study it. And then Thursday next week, we take the test in here. So it's over sections 1 to 5. Questions? I'm giving you kind of a heads up. Monday, I believe, is the Monday coming up. This Monday coming up is one of the last days you can turn in page 18, I believe. 18 is the 0 dates coming up for Monday, so if you check the grade book, you're missing page 18. Monday is the last day you can enter it. That's the 10th day after I signed it. Next Friday is the end of midterm, so any redo assignments I've passed back to you, it's due by next Friday. Did I? Yes,
Isaac Bell, Ethan Tail, Ashton Lebowski,
$1,356 later.
What color did you get?
Black.
Nicholas Martinson,
All the other
Adam
colors are still.
Natalie Navarro,
The popular one this year will be green. That'll be the
Jacob
popular.
Cash,
Good at all.
Savannah
No,
Dietrich,
I don't like the gold.
Ben
It's just kind of very
Marshall,
white.
Logan Smith, and Charlie Young. You have nothing in the
One of
office.
those things, like I pre-ordered it this morning, they'll be here by Friday. There's a green this year. That was the most popular color because it's the new color.
Right.
So,
Olivia Dinger, you have something in the office?
yeah, it'll be here by next Thursday supposedly. I got one of the first orders. Yeah, I got a racing shirt before. I just remembered that. It was like, right when you walked in, I was like, I didn't even put a scene shirt on the board. Probably should do that.
Mr. Ward, can I do my page 18? My page 18.
Yeah.
Can I get it?
Yeah.
I have to erase it.
Back again.
Jesus.